Welcome back, students. Right now we're going to be talking about the trigonometric ratios. Now, in order to talk about that, we need to learn a specific phrase. So, ka, toa. All right, so with this is going to help us to identify all the ratios in these triangles that we're going to be dealing with. This only works with right triangles, so make sure to pay attention to that. All right, so first let's identify an angle of interest. All right, so let's identify this as our angle of interest. Now that means that the side that's completely opposite of it we will call opposite. The side that is, well, and I guess we should say the side opposite of your 90-degree angle is always the hypotenuse. The hypotenuse is always going to be your longest side as well. So we've got opposite of the angle we're interested in. Opposite of the 90-degree angle is the hypotenuse. This remaining side that is touching our angle of interest, we call it the adjacent. Okay, so what all this is going into is that when you are trying to find the sign of a number, it is going to give you the opposite over the hypotenuse. Okay, if you are trying to find the cosine of an angle, it will give you the ratio of the, that shouldn't have happened. All right, it should give you the adjacent over the hypotenuse. And if you want to find the tangent, it'll give you the opposite over the adjacent. Okay, so ka toa. It's just a quick word that should help you to identify what are the parts of the ratio. All right, so we are looking in this problem for the sine of z, which makes this our angle of interest. So we've got over, oh, and I mislabeled something already. So first, opposite of the 90-degree angle, this is our hypotenuse. Opposite of the 90 will be called opposite, and the remaining angle that is touching it is the adjacent. Now, sine is always going to give us opposite over hypotenuse. So the answer to that question is a 16 over a 20, the opposite over the hypotenuse. And we could, of course, simplify this one to then be 4/5. And there's our answer. All right, right here it is asking for sine of A. So right here at A, that's our angle of interest. And we know that the longest side is the hypotenuse. The side opposite our angle will be the opposite. So this remaining side is the adjacent. Now, sine will always give opposite over hypotenuse, the so in the SOHCAHTOA. So we are going to have 20 over hypotenuse of 25. I'll go ahead and simplify that down to 4/5. Well, that's interesting. So it looks like angle A and angle Z must have been exactly the same. All right. So now we're going to do it with cosine. Remember that cosine is going to be the adjacent over the hypotenuse. All right, so let's start labeling. It wants the cosine of C. So, and it did it again. All right, so cosine of C. We care about this angle right here. So here's our hypotenuse. This is the opposite side. And here's our adjacent side. We want the adjacent, 30, over the hypotenuse, 34. Okay, that'll then simplify into 15/17, and we're done. We've identified the ratio. Cosine of x, we have our hypotenuse. We have the, oh, I should figure out which is the angle I'm interested in. So cosine of x. So over here is the opposite. And there's the adjacent. Cosine should be the adjacent over the hypotenuse. So the answer is 3/5. All right, we want the tangent of z. Remember, tangent is the TOA. So opposite over the adjacent. All right, so first we've got hypotenuse. We care about angle z. So there's our opposite, and there's our adjacent. So TOA, opposite over adjacent, 30 over the 40. So 3/4. Tangent of A. Our longest side is the hypotenuse. This side touching the angle is the adjacent. And the one on the opposite side is opposite. So opposite over the adjacent should give us a 5/12. Okay. So we've now got those. In these next problems, we're going to need to use some inverses to do these. All right, so let's first notice what we have. We're given an angle right over here. We are looking for the hypotenuse. And what we have over here is the opposite side. So we need to use a trig function that is going to use both opposite and hypotenuse. So that would be the sine, the SO in SOHCAHTOA. So let's go ahead and set this up. This would be the sine of 41 degrees should be equal to the opposite over the hypotenuse, x. So now we just need to solve for x. So I'm just going to go ahead. I don't like that x is in a denominator, so I'm going to work with that first. So now I've got x sine of 41 is equal to a 13. So now I can just divide by the sine of 41 on both sides. So x equals, let's go ahead and use a calculator to figure that out. So 13 divided by sine 41. So it's going to be approximately a -82. Okay, and we have found x. Now, this part right above it, this would be considered the exact answer. Because we didn't simplify, we didn't round anything. So if ever you're asked for the exact answer, that's what you'd be given. All right, let's move on to the next. We've got this angle. Looks like we've got the opposite side. And right up there we have the hypotenuse. So once again, we're going to be using sine. So sine of the 38 degrees is equal to the opposite over the hypotenuse. Well, this one's going to be much easier to solve because x is in the numerator this time. So I'm just going to multiply both sides by 13. And x will equal, so 13 sine 38. And we get about a 3.9. Okay, and so that's what that missing side would be about. All right, in these next two, so we've got this angle right here. We've been told the hypotenuse, and we are looking for the side that's adjacent, which means we're going to be using cosine. So the cosine of 53 degrees should be equal to the adjacent x over the hypotenuse, 13. All right, so same as last time. X is already in the numerator, so I'm just going to multiply both sides by that denominator to eliminate that. And now we have x is equal to 13 cosine of 53. So negative 11.9. Let's change that to approximate. Okay, we've got this angle right here. Got our adjacent and the hypotenuse. So cosine of the 55 degrees must be equal to the adjacent over the hypotenuse. Let's multiply both sides by 19 to get x alone. And x is going to equal to 19 cosine 55. Oh my goodness, I have made a terrible mistake. I have been, so if you'll notice up here on my calculator, when you do sine and cosine, it makes a difference as to whether or not you're working in degrees or radians. I've been accidentally working in radians, and I needed to switch that to degrees. All right, so that's going to make a big difference here. I'm just going to press enter again for this 19 cosine 55, and you can see how that suddenly changed those values. Okay, so whatever calculator you use to do this, make sure that it's set to whatever you're using. If you're using radians, then make sure it's set to radians. If it's degrees, make sure it's set to degrees. All right, so that should be 10.9. And let's fix some of these others. So 13 cosine 53. Should be a 7.8. Which, I feel silly now. Notice we had got a negative number there before. We're trying to find the length of the side of a triangle. It would be impossible to get a negative length. And had I been paying attention to what I was doing, I would have noticed that I even did it twice. All right. So let's see, this 13 over sine of 41. So 13 divided by sine 41 should give us 19.8. Okay, and then 13 sine of 38. And that's approximately 8. All right, so now that I've fixed that mistake, and I'm not going to edit it out because, hey, maybe that's useful to some people in the future to recognize that you need to be paying attention to what it is using. All right, so here's our angle. We've got the adjacent. Our hypotenuse is right here, and the opposite. So we've been given the adjacent and the opposite. So that's TOA. The tangent of 55 should be the opposite, 18, over the adjacent, x. All right, so I'm going to multiply both sides by x so that x is out of that denominator. So the tangent of 55 is equal to 18. Divide both sides by the tangent of 55. So x is going to equal 18 over tangent of 55. All right, 18 over tangent of 55. 12.6. All right, here we've got this angle. We've got the adjacent. We've got the opposite. So the tangent of 72 degrees must be equal to the opposite over the adjacent. Multiply both sides by 10, and we'll just have 10 tangent of 72. So 30.8. All right, so that's the length of that side. Okay, for the remainder of this, we're going to go back a bit to the unit circle. And the ideas around there. Now, there's a couple of ways you could approach doing problems like this. Now, one thing I'm noticing right off the bat, if I were to type this into a calculator, notice I'm using pi and pi fourths. Gotta switch that back to radians. Okay. However, I want to find the exact values this time. The calculator is not great for finding exact values. It's great for rounding and getting those decimals, not so much for exact values. So what we are going to do here is first I'm going to try to figure out these problems using a sketch of the unit circle. All right, so let's imagine, here's our unit circle. Now, first we're taking the sine of 2 pi. Now, to do 2 pi, that meant I went all the way around the circle. Now, that would have been 2 pi, but notice it's now minusing a pi fourths. Now, because it's minusing the pi fourths, so I'm going to start right where I ended, and I'm going to go back the distance of a pi fourth. Now, if you don't remember what is the distance of a pi fourth, you should probably open up a unit circle, okay, which would show you it went up just at a 45-degree angle. Now, I did that same distance but I did it going down. So that's going to put us about right here, which on my unit circle is going to be a square root 2 over 2 and a negative square root 2 over 2. We want the sign, so we want the y value. So that's my answer right there, negative square root 2 over 2. Now, that's me imagining kind of what's happening using the unit circle. There is another way of approaching this. We can go ahead and figure out what radians we're using by adjusting what's in there. So I could do sine, and I want to make 2 pi have a common denominator. So I would multiply it by a 4 over 4. So I'd get 8 pi over 4 minus a pi fourths, which would then just be the sine of 7 pi fourths. Okay, and I would look up 7 pi fourths on my unit circle. Guess where it's at? That exact same place. Okay, so you can try and imagine you moving along the unit circle, which could be one fast way. Or if that's tricky for you, go ahead and make your two numbers have common denominators, and then figure out where that would be. Find the coterminal angle on the unit circle. All right, so this one is, notice it says pi, so we're going to start out at pi. So we're over there on this side, and now it's adding a 3 pi fourths. So on a normal unit circle, we can find 3 pi fourths, and it looks like we come up, and 3 pi fourths would be right there in the middle. Now, main thing I'm paying attention to is that distance, how far it goes. So notice how it goes in 90 degrees, and then another 45 degrees past that. So coming back here, now we are adding it, so I'm going to continue that, and I will go the 90 degrees and another 45 degrees past that. So there that is. Now, this actually turns out to be that exact same point of square root 2 over 2, negative square root 2 over 2. Both of these statements were coterminal. So our answer is negative square root 2 over 2, because once again we were looking for the y value because it's sine. Looking at that from just adding our fraction, we would change pi to 4 pi over 4 plus a 3 pi over 4, and that's going to give us sine of 7 pi over 4. So no wonder we got the same answer. All right. So next one, we got cosine. And this, there we go. Come on. Does not want to draw over on that side for some reason. All right, there we go. I think that fixed it. All right, so we've got this. Pi would be right there on the unit circle, and we are going an extra pi thirds. So pi thirds is just that. So we're going 2/3 the way up. It is a 60-degree angle. So we are going to be adding a 60-degree angle to this. So going down there. Okay, so that a 60-degree past the pi. Notice, same distances, just we had started at a pi with this one, would bring me right here. And we wanted the cosine, -1/2. Okay, because we got -1/2 and -√3/2, but it's cosine, so we wanted that x. Okay, we also could have done this by doing 3 pi over 3 plus pi thirds, which is then going to give us the cosine of 4 pi thirds. And if we look back at that unit circle, sure enough, that's exactly what that line was, 4 pi thirds. Okay, all right, so I'm going to end it there. I hope that helps you with your work. Good luck.